See, the topic is for this video problems on ratio test, D'Alembert's test and Rabi's test. You know what is D'Alembert's ratio test? Now I apply that ratio test to solve infinite series, to test the convergence of series. What does D'Alembert's ratio test says? D'Alembert's ratio test, it is like this. Suppose sigma un is a positive term series and un plus 1 upon un is equal to L, that is limit un plus 1 upon un is L, then sigma un converges if L less than 1, diverges L greater than 1. L is equal to 1, test fails. Test fails. And Rabi's test is again we consider positive term series only. If limit n into un upon un plus 1 minus 1 n tends to infinity is L, then sigma un converges if n is greater than 1. Carefully observe this one. L greater than 1 converges. In D'Alembert's test, L less than 1, sigma un converges. And diverges if L less than 1. Again test fails when L is equal to 1. Now I apply this test to solve some more examples. After that, two tests left. One is Cauchy's integral test. Then for alternating series there is one theorem, Leibniz test. Now consider problems on this. Discuss the convergence of the series sigma 4, 7, etc. 3n plus 1 into upon 1, 2, etc. n x raised to n. This is the given series. Test the convergence of this. First, for this type of series, that is nth term is ratio, then we apply ratio test. Suppose nth term is involves power, that is raised to n, root n, so on. In that case we use Cauchy's root test. Now what is un here? Here let un is 4, 7, etc. into 3n plus 1 upon 1, 2, etc. into n x raised to n. So un plus 1 is 4 into 7 into etc. 3n plus 1 into 3n plus 4. N plus 1 means un plus 1 means one more term you have to take. Next term of this, what is that? 3 into n plus 1 plus 1, 3n plus 4. 1, 2, etc. into n plus 1 into x raised to n plus 1. This is un plus 1. So we consider first D'Alembert's ratio test. For that we consider un plus 1 by un, n tends to infinity. It is limit n tends to infinity of un plus 1, 4, 7, etc. into 3n plus 1 into 3n plus 4 upon 1, 2, etc. n into n plus 1. It is into 1 into 2 into n plus 1 x raised to n plus 1 into, see, divided by un means multiply the reciprocal of this 1, 2, etc. into n divided by 4, 7, etc. 3n plus 1 into x raised to n. This is un plus 1 by un. Take limit of this as n tends to infinity. Limit n tends to infinity. Simplify like this. Up to 3n plus 1 cancels. Up to n cancels. We get x upon x, or I write 3n plus 4 into x upon n plus 1. N plus 1. Now take the limit of this, and convergence and divergence depends on limit of this. It is limit n tends to infinity. How to take limit n tends to infinity? Always to take limit n tends to infinity we use 1 upon n tends to 0 as n tends to infinity. So 3 plus 4 by n divided by 1 plus 1 upon n into x. It is therefore 3x. Therefore, by D'Alembert's ratio test, sigma un converges if 3x is less than 1, that is x less than 1 by 3, and diverges if 3x is greater than 1, that is x greater than 1 by 3. And test fails when 3x is equal to 1. Test fails when x is equal to 1 by 3. X is equal to 1 by 3. Now, when x is 1 by 3, we apply Rabi's test. That may work here, Rabi's test. That may be applicable. Now, consider what is Rabi's test. Limit n tends to infinity of n into un upon un plus 1 minus 1. So, limit n tends to infinity n into what is un upon un plus 1? This is un plus 1 upon un. In a D'Alembert's ratio test, we have obtained up to this step un plus 1 upon un it is. But here we require un, therefore n plus 1 upon 3n plus 1, 3n plus 4 into what is x? X is 1 by 3, therefore it is 3 it is, correct? 3 because x is there, divided by x means into 3. This is un plus 1 upon un plus 1 upon un when x is 1 by 3 minus 1. Therefore, it is limit n tends to infinity n into 3n plus 3 minus 3n minus 4 upon 3n plus 4. 3n plus 4. Therefore, limit n tends to infinity of n into 3n cancels minus 1 upon 3n plus 4. Upon 3n plus 4. Now, what is the limit? It is limit n tends to infinity of minus 1 upon 3 plus 4 by n minus 1 by 3. So, it is less than 1. By Rabi's test, sigma un diverges. Because when in Rabi's test, what does Rabi's test says? If limit n into un upon un plus 1 minus 1 is greater than 1, then converges. Less than 1, diverges. Therefore, sigma un diverges by Rabi's test when x is equal to 1 by 3. Therefore, the given series sigma un converges if x is less than 1 by 3 and diverges if x is greater than or equal to 1 by 3. This is the conclusion. So, the given series converges if x is less than 1 by 3, diverges for x is greater than or equal to 1 by 3. Next is this problem. Take this. Discuss the convergence of sigma 1 square, 4 square into etc. 3n minus 2 square upon 3 square, 6 square etc. 9 square into 3n square. 3n square. Now we first apply this type of problem. So we first apply D'Alembert's ratio test. Therefore, what is the problem? Discuss the convergence of the series where series is this. Therefore, we take un is this. Un. What is that? Yes, 3n minus 2 square and 3n minus 2 square. Denominator last term is 3n square. So un plus 1 is 1 square into 4 square etc. 3n minus 2 square into 3 into n plus 1, 3n plus 1 whole square divided by 3 square into 6 square etc. into 9 square etc. 3n square into 3n plus 3 square un plus 1. Therefore we take un plus 1 by un. To apply D'Alembert's ratio test, we take un plus 1 by un. It is, what is un plus 1 by un? I write here un plus 1 upon un 1 square 4 square etc. into 3n minus 2 square into 3n plus 1 square divided by 3 square into 6 square into 9 square etc. 3n square into 3n plus 3 square into upon un is, it is 3 square into 6 square into 9 square etc. 3n square upon un means you have to multiply by the reciprocal of this, upon 1 square 4 square etc. into 3n minus 2 square. Now simplify this, up to 3n square cancels and 3n minus 2 square cancels. So we have un plus 1 upon un is, it is 3n plus 1 whole square upon 3n plus 3 whole square. 3n plus 1, 3n plus 3. Now limit n tends to infinity of un plus 1 by un is, limit n tends to infinity of 3 plus 1 by n, 3 plus 3 by n whole square, it is 1. So what is the conclusion? Ratio test fails here. D'Alembert's ratio test fails. Fails in the sense we cannot draw any conclusion from this since limit is 1. Now we apply Rabi's test. For that, consider limit n tends to infinity of n into un upon un plus 1 minus 1. See the limit, we take un upon un plus 1 n into, therefore limit n tends to infinity n into, what is un upon un plus 1? 3n plus 3 whole square upon 3n plus 1 whole square, un upon un plus 1, reciprocal of this, minus 1. Limit n tends to infinity of n into 3n plus 3 whole square, 9n square plus 18n. Am I correct? 3 into 3, 9 into 2, 18n plus 9 minus 9n square, taking LCM, 3n plus 1 whole square, minus 9n square, minus 6n, minus 1. Therefore, this cancels. 18 minus 9. N tends to infinity of 18 n minus 6n. 18 minus 6. 12 n square plus 8n divided by 3n plus 1 whole square. 3n plus 1 whole square. Now take the limit. It is limit n tends to infinity. Divide numerator denominator by n. We get value plus 8 by n divided by 3 plus 1 by n whole square. Dividing numerator denominator by n square. Am I correct here? Verify here. Dividing by n square. Here also n square. We get 3 plus 1 upon n whole square. As n tends to infinity, what is the limit? This is 0, 1 by n is 0. 12 by 9. 12 by 9 means 4 by 3 greater than 1. So what happens? Given series converges. Given series converges. Is it correct? Verify again. N into un upon un plus 1 minus 1. N into 3n plus 3 whole square upon 3n plus 1 whole square minus 1. N into 9n square plus 18n plus 9 minus 9n square minus 6n. 6n minus 1 upon 3n plus 1 whole square. 8 minus 12n square it is. 12 by 3, 12 by 9, 4 by 3 greater than 1. What is the conclusion of Rabi's test? In Rabi's test, if this limit n un upon un plus 1 minus 1 is greater than 1, it converges. It converges. So, given series converges. This is by Rabi's test. Greater than 1, therefore converges. One more problem. Test the convergence of the series. Test the convergence of the series whose nth term is 1 plus a plus a into a plus 1 by 1 into 2, a into a plus 1 into a plus 2 by upon 1 into 2 into 3 plus so on. What is a? A greater than 0 here. A greater than 0. Now let un is 1 plus a into a plus 1 by 2 plus a into a plus, what is un? Un is, we leave the first term here for generalization. You know that in a series, infinite series, we can add some terms, or at the same time we can leave some terms while discussing the convergence. It doesn't affect the convergence or otherwise divergence of the series. So we leave the first term and un is a into a plus 1 by 1 into 2, a into a plus 1 into a plus 2 by 1 into 2 into 3 plus, what is the nth term? A into a plus 1, a plus 2, etc. a plus n minus 1 divided by 1, 2, 3, etc. n. Correct? 1, 2, 3, etc. n. Now, consider, first we use usually D'Alembert's ratio test. D'Alembert's ratio test. Un is this, not un, it is a given series, correct? Given series is this, by neglecting the first term or omitting first term, this is the given series. Therefore, un is a into a plus 1, a plus 2, etc. a plus n minus 1 upon 1, 2, 3, etc. into n. Un plus 1 is a into a plus 1, a plus 2, etc. a plus n minus 1 into a plus n, divided by 1, 2, 3, etc. n plus 1. Therefore, un plus 1 by un is equal to, what is un plus 1 by un? A plus n divided by n plus 1. N plus 1. A plus n, because a plus n remains numerator. Denominator. What is the denominator? N plus 1 remains, because up to n cancels. Now limit n tends to infinity of un plus 1 by un. It is limit n tends to infinity of a by n plus 1 by 1 by n 1 plus 1 by n. What is the limit? 1. Again, D'Alembert's ratio test fails here. We cannot come to any conclusion when limit is 1. You know that D'Alembert's ratio test. D'Alembert's ratio test fails. So we consider Rabi's test. Consider limit n tends to infinity of n into un upon un plus 1 minus 1. It is limit n tends to infinity of n into, this is, what is this? This is un plus 1 upon un. What is un upon un plus 1? Reciprocal of this. N plus 1 by a plus n minus 1. Limit n tends to infinity n into n plus 1 minus a minus n upon a plus n. Therefore it is limit n tends to infinity of 1 minus a into n by a plus n. Now first find out value of the limit, because convergence or divergence depends on the value of the limit. It is therefore limit n tends to infinity 1 minus a divided by a by n plus 1. It is 1 minus a. Therefore sigma un converges if 1 minus a is greater than 1, that is a is less than 1. Diverges if 1 minus a is less than 1. This is by Rabi's test. 1 minus a less than 1, given series diverges. That is a is 1 minute. 1 minus a is greater than 1 means, correct? A transpose here. A less than, is it 0? 1 minus a is greater than 1. Therefore transposing a is less than 0. It converges. And 1 minus a is less than 1. This diverges. Therefore a is greater than 0. This diverges. A less than 0 converges. A greater than 0 diverges. And a is equal to 1. A is equal to 0. Correct? 1 minus a is equal to 1. Correct? 1 minus a is equal to 1. Test fails. A is equal to 0. Test fails. When a is 0, then what happens? A is 0, you will get the given series as, when a is 0, given series is only 1. What is the given series? I think up to this you have followed this one. A less than 0 converges, greater than 0 diverges. If a is equal to 0, then see what happens. A is 0, 1 minus a is 1, test fails. D'Alembert's Rabi's test fails. 1 minus a is equal to 1, a is equal to 0. The given series becomes, given series is, a is 0 means only 1. Because what is the given series? 1 plus a into a plus 1 by 1 into 2, a into a plus 1, a plus 2 by 1 into 2 into 3, etc. Correct? So the given series is 1. Therefore converges. converges. So a less than or equal to 0 converges and a greater than 0 diverges. Greater than 0 diverges. In the beginning, we don't have any idea about a. We didn't have idea about a, but a is this now. A less than or equal to 0 converges, greater than 0 diverges. I will consider some more examples later on this series, that is D'Alembert ratio test and Rabi's test. Next is what is that? Cauchy's integral test. Cauchy's integral test. First, see what the test says. Statement is like this: let fx be defined. Fx be defined for x greater than or equal to 1, and it is a positive monotonically decreasing function of x. Monotonically decreasing function of x. Let f of n is a n, means f of 1 is a1, f of 2 is a2, etc. f of n is a n for all n. Then sigma a n 1 to infinity, and the integral 1 to n or 1 to infinity fx dx either both converge or do not converge. This is called Cauchy's integral test. What does test say? Study carefully the integral test, because convergence of the infinite series depends on convergence of this integral. It is called improper integral. It is 1 to infinity fx dx is called improper integral, and it is easy to consider 1 to infinity fx dx. And when do you say that 1 to infinity fx dx converges? This is again a separate topic. It is called improper integrals, and I think you have studied improper integrals. This year only you have studied in 6. No, you are supposed to study this in next semester. Improper integrals. Improper integrals means here 1 to infinity. If one of the limit is infinite, or both the limits are infinite, or the function fx is not unbounded, then the integral a to b fx dx is called improper. See, a to b fx dx is called improper if one of the limit is infinity, or both the limits are infinity, or limit is finite but fx is unbounded. Then it is called improper integral. And their improper integrals are again further classified. They are into different types. And come to this is improper integral because this limit is infinite, and we say that this converges if limit 1 to t fx dx as t tends to infinity exists. If this limit exists 1 to t fx dx, then we say that this converges. Suppose this doesn't exist, it tends to infinity, we say that this diverges. Therefore, now it is here sometimes primitives are easily obtained. This integral fx dx can easily obtain. In such cases, the convergence of this sigma an can be studied with the help of this improper integral. Say, condition important here. What is the condition? Fx is positive and strictly monotonically decreasing, for all x greater than or equal to n, monotonically decreasing, and then sigma an and sigma an and 1 to infinity fx dx, they are alike, behave alike. What is an? F of n, and this is called Cauchy's integral test. I prove this test and solve some examples in the next period. Before that, why I had given the statement is, you study the statement here, then problems to apply this to solve the problems, first you should be thorough with the statement. What is the statement? Condition important here, fx is positive and it is monotonically increasing for all x greater than or equal to 1 here, positive and monotonically decreasing, and an is equal to f of n for all n, then sigma an and 1 to infinity fx dx behave alike, either both converge or both do not converge. I consider the proof of this in next period and also problems on this.